Hi guys, it is Mr. Dave with the RayKitty Creation Workshop, and you are watching the RayKitty Science Project. Thank you for tuning in and being part of our project and part of the science. So today we are going to do some science as far as a little safety warning. This is one that you would want to do with adults. One of the materials in particular that we will be using, which is sodium hydroxide. You'll want to be careful with that one. As I like to say, it is hazardous, not dangerous, okay? Hazardous means if you handle it improperly, it can cause some slight chemical burns to your skin. Dangerous means even if you're handling it correctly, you can hurt yourself. This is not dangerous, it's hazardous. But you'll want to make sure that you have an adult around for these ones here. So these are the two things we're going to be doing today. Both of these are oxidation and reduction experiments, okay? And that's with the gaining and losing of electrons, okay? So if you are going to kind of some of the higher level science with these ones here, that oxidation is when it is losing electrons and reduction is when it is gaining electrons, okay? So when we're looking at that, and a lot of chemistry has to do with oxidation and reduction. Electrochemistry, like we did before, that's oxidation. When you see a penny that is turned nice and green, that is oxidation, okay? So it is giving off those electrons, okay? So in this one here, we have two different oxidation and reduction ones we're going to do. I'm going to jump right into the first one, and I'm going to begin mixing it while I'm telling you what you're going to need, because this one does take a little bit of time. This is called an iodine clock reaction, okay? And so I'm going to get started where we've got vitamin C tablets, 1,000 milligrams, iodine, liquid starch, and peroxide, okay? Water and a couple different beakers, okay? Now, another thing to kind of be cautious with, iodine can stain things very badly, very quickly. So that is something to just kind of be aware of, okay? So first what we're going to do is we are going to take our little tablet here of vitamin C, okay? This is 1,000 milligrams of vitamin C in this tablet. You can do it lots of different ways to get that 1,000 milligrams of vitamin C, but I'm going to take a tablet and I'm going to crush it, okay? If you were in one of my younger classes, we would use the term smoosh, okay? We are going to smoosh this, and that is a scientific term. And we're going to want to crush it pretty fine. Now, as you can see, I'm just using my spoon here. They crush fairly easily. You will want to make sure that when you are buying the vitamin C, if you're not buying it in a powder form, that the tablet is just vitamin C. Sometimes they'll have other materials in there or other vitamins or minerals in there, and you don't want that. You want straight up vitamin C, okay? So this is going to be our solution A, okay? And this is our vitamin C. So we have 1,000 milligrams of vitamin C there, okay? And I am going to put it into 2 ounces of water, okay? So I've got my water here, and we have 1,000 milligrams of vitamin C that we're putting into 2 ounces of water, okay? I'm doing it this way because this is the easiest way to kind of do it at home. Now, we're not going to be using all of this material. If you are doing this one in a classroom or you are doing it with your family, you can crush 1 tablet, and we're going to use 1 teaspoon of this solution, okay? So we're not going to use all of that solution. It's just a way easier way of getting it measured out, okay? So I'm going to stir up my solution there, get that vitamin C in there, and allow it to kind of dissolve just a little bit in our water, okay? I made a little bit of mess on the table. We won't tell anybody, okay? There you go. See, look at that. Now it's gone. All right, so when we're mixing our vitamin C, it may all dissolve. You want to get it dissolved as well as you can so that you have a nice even mixture there. But as you can see, I've got little floaties on the top. That's no big deal. Now we have iodine is the other part that's going to be part of our first solution, okay? Now remember, as I said, we're not using all of this. We're only going to be using 1 teaspoon of our vitamin C stock or our vitamin C solution, okay? So I have a half teaspoon here, and I'm going to be now taking this from our solution here, and I'm going to be putting it into another 2 ounces of water, okay? I'm going to get 2 scoops because I have a half teaspoon here. The reason is it just works a little bit easier for transferring it. As I said, you're not going to need the rest of this. This was just for making that solution, okay? So now in here, we have a little bit or 1 teaspoon of our vitamin C solution into 2 more ounces of water. Now we're going to add our iodine, okay? Now the iodine, we are going to want 1 teaspoon of iodine. Now, as I said, remember, be careful with the iodine as it does stain. I am going to just pour it right above this here. This is a half teaspoon, so I'm going to want 2 of those. So I'm going to put 1. Now, the first fun part of this is to watch what happens when I put the iodine into the vitamin C, okay? So when I put it in here, you're going to notice that that color goes away, okay? So there's 1. And a 2, okay? Now don't go to 3 because we know that that would get you to the center of a Tootsie Roll Tootsie Pop. So we have our iodine in there, and look at when we mix it up, that's the first wow on this one here, is that it is seemingly colorless, okay? Now I say seemingly, what has happened is we're not able to see that color right now, and that's pretty important in kind of over the long term of this experiment. So now we have 2 ounces of our iodine and vitamin C stock. This is going to be A, okay? So we're just going to call that one A. Now, I have 2 ounces of water here. Let me check my little chart here, make sure I have all the right stoichiometry. Stoichiometry, again, is making sure you have the right ratios of things, okay? So I am now going to put in our hydrogen peroxide, okay? Now we're adding this again to 2 ounces of water. So this is the same amount of water that's in there, but we're going to do it right in our beaker, okay? So for this one here, we are going to want a total of 3 teaspoons. So 6 of these little guys here, okay? So I'm going to put this hydrogen peroxide in there. Now this one will be very dramatic. Are you ready? Because look. Oh, yeah, nope, that's it. Yeah, I'm just kidding. Okay, so we want 3 teaspoons. So there's 1, 2, 3, 4, 5, and 6. Okay. Now, hydrogen peroxide is used very, very often in oxidation and reduction experiments. Hydrogen peroxide. Okay. That means there is 1 hydrogen molecule for every oxygen molecule. Now, what we have here is our hydrogen peroxide solution. I am now going to add some of our liquid starch, okay? You can argue with your family whether this is called stay flow, staff flow. There's so many different ways that I've heard this. You can use any old brand, but you want liquid starch, okay? So we're going to use our liquid starch, and we are going to put it in here, and I am going to do half a teaspoon of this liquid starch, okay? Remember, that is our measurement that we're using here. The cross-contamination is not super important. You may notice I'm using the same little spoon for all of them. I'm wiping it off in between, but because we are going to be combining all of these, that cross-contamination is not super important. Okay, so I'm going to put this in here. I'm going to stir this one up, and now we have our A and B solutions. Okay, so we have our 2 different solutions. This one is the iodine and the liquid starch. This one is our vitamin C and our iodine, okay? Now, when we pour it in here, remember that I said this was an iodine clock reaction. So what we're going to see at first is nothing, okay? So I'm going to pour this in here. I'm hoping we see nothing. So I'm going to pour this one in here. A whole lot of nada, okay? Not a lot is happening there. But what I want you to do is to continue to watch this one while we do our next experiment. Okay, so I'm going to put this one on the table right in front of me here. I'll move it over to the side just a little bit. And you can drink this one, but don't drink that. It's pretty tangy. All right, so I'm going to put this one right here. Make sure you guys can see it okay. We're going to be watching this one, and I'm going to be watching it out of the corner of my eye while we're doing our other experiment, because that iodine clock reaction is actually happening right now, even though we don't see it, okay? Because in here, that starch is actually not allowing that reaction to happen yet, but it is breaking down, okay? And when it breaks down enough, then we're going to see that one happen. So we're going to keep an eye on that one. Hopefully it happens before the end of our program. So this next one that I'm going to do here, this is called a chemical traffic light, okay? And I like to do this one here because as a New Mexican, I promise I wasn't checking my Facebook there. I was making sure I get my stoichiometry correct. Because as a New Mexican, I do know that a traffic light is strictly for suggestions, okay? So when you're doing this one here, we're going to be using, as I mentioned before, that sodium hydroxide, which is a little bit, we want to be careful with that one there. I have a little beaker of water here. This one, just like our other iodine, this is indigo carmine. And this one will stain even more than that one, okay? This is very, very powerful, and they actually use it. They used to use it in staining blue jeans. Yes, I'm old enough to say blue jeans, but this is the stuff that when you wash your pants with everything else, everything turns blue, right? And that's this stuff here. And we can see that you just need a tiny, tiny bit of that. So I'm going to put a little bit of that into this one here and create kind of a little mixture. Now, I'm not even going to open the lid. This is how little of this we want. If you look very closely here, you're going to see I'm just kind of getting the, just turning the lid to where a little bit of that falls in there. That is all we need of that, okay? Very, very little. And you can see it turns that beautiful blue, okay? But the thing about this indigo carmine is it is actually a indicator, okay? Meaning it will change colors based on the pH of what we're putting it in, okay? So we have our indigo solution there. Now we're going to make the rest of our solution. I have water here. I have dextrose, okay? Dextrose, you can use the term glucose or you can use the term dextrose. You can buy this at a health food store. It's inexpensive for a lot of it. It's an artificial sweetener, so you can use it for making your food almost taste good. Yeah, so we have our dextrose here, and I'm going to put 2 teaspoons, I have my other teaspoon here, of this dextrose into our water here, okay? Now, as you can see, I had a little bit of that indigo in this when I was doing some earlier ones, so we're already turning that nice, pretty blue, okay? And so we see that the dextrose already reacted with just that tiny, tiny little droplets of that indigo that was in there, okay? So we have our dextrose, okay? Now we are going to put this in here. This is the one that you do want to be careful with. Don't get it on you. If you do get it on you, this one is not something that will immediately hurt you, but you will want to wash it off right away just to kind of take care with this one here, okay? So with this, oh, wait. I missed it. Look what happened over here. While we were pouring it, our other iodine clock reaction took place. So we actually had a change and it went to this nice, beautiful black. Now you say, well, why didn't I see it happen? Because it happens instantly, okay? It goes from clear to black instantly. Now, if you are doing this one at home, because these are all materials that you can use at home, that you probably already have in your bathroom. If you are doing these ones at home, you can time it. You can watch it like in a slow motion camera. And even with a slow motion camera, it's hard to catch because that iodine, remember how I said the iodine was still there, we just couldn't see it? Now that iodine has reacted and turned this crazy deep, deep, deep black. Okay, so the indigo clock is a fun one, and that is one that you just kind of watch. You can time it if you're doing it for a science fair. Yes, I keep plugging the science fair. If you're doing it for a science fair, this is a fun one to put different amounts of each of your materials in. See if you can make the reaction last longer or take less time. Another factor in this one is if you use hot water versus cold water. Cold water isn't going to react as quickly, so you can have it go forever. So if you are watching this video and if you're watching it later and you're watching it online, you could back it up and you could see that stuff change, and you can watch the second that stuff changed. So that's a fun one there. I'm glad it happened while the episode was going. Sometimes I'll do that one and then it just takes forever. So you got to make sure that your stoichiometry is correct and that you are using warm water if you want it to be a little faster. All right, so I'm going to add to this one here, and I am going to do 1/2 teaspoon of our sodium hydroxide. Okay, and this is the same type of reaction as we had over here. Okay, it's a color changing reaction. You can see already that color has changed. Okay, as soon as I put that in there, we got a little bit of a change in that color. And so I'm going to put the indigo in there, and we're going to have a little bit of fun with this one. Now, make sure I don't use this one. We're going to use this one here. And if you are watching this later on YouTube or whatever, make a comment as to the time when that thing changed, because I'd like to go back and watch it too. All right, so I'm going to put some of this indigo in here, and let's watch closely as I put this in here. We can see that it's changing to that nice, pretty green color. And that's fun, right? Yellow and blue make green. That's pretty obvious. But this has got a lot more to it. So I'm going to dry it off so that I can shake it around here a little bit. When I shake this one up, you're going to see that we get a nice, pretty, pretty green color that's happening. Now, a traffic light, as you may know, like New Mexicans, all traffic lights are always this color all the time. That's just how it works, right? But in reality, a traffic light has 3 different colors, right? We have green, red, and yellow, right? Yellow really exists on a traffic light, I promise. But what's going to happen here, if I've got my stoichiometry correct, and I may have to adjust just a little bit because I did use water from here in the studio. All water has got a different pH balance, but what we did when I shook it up was I'm oxidizing it. Okay, so I am actually, that the air around it is stealing those molecules, and we're changing it into that nice pretty green color. When this solution is oxidized, it turns green. Okay, now just like this one here, how we watched it or I wasn't watching closely enough, but just like this one here, eventually this went and turned to that nice dark black. What's going to happen here is this one is also going to change colors. Now this is actually got 3 different color changes that happen to this one. We go from our green to a red and then to yellow. Okay, so we actually have 3 different colors that will happen in this little beaker here. And so while we're waiting and watching that one and seeing if that one's going to change for us, this one here, we're going to talk about what happened. Okay, so the same thing is happening here, but remember how we talked about that starch, right? If we didn't have that starch in there, okay, the vitamin C would have been absorbed right away, and this would have changed right to that nice black color. But the starch actually came in the way or got in the way of our reaction. Okay, so we weren't able to see anything happen right away because that starch was in that water. Well, it was broken down, and as it was broken down, it ended up that it was broken down enough, and it happens, as I said in this one, instantly. If you're watching this one again later, this is a fun one because it does happen pretty much instantly. Now this one here is not happening quite as quickly as I was hoping for, but what I did, just in case, was I did bring another one. So what I did was I brought a backup. Now, the reason that we had the change here is because oxidation and reduction are a pH change, okay? So you're going from an acid to an alkaline. And this one here, the water that you use, as I said, you can use different places. You can use distilled water, and it'll usually be close to that number 7. But I like the fact that we can actually test different waters from different places. This was with the water from my house. This one was with the water here. Now, at my house, my water filter had just run, so the pH balance was changed in my water. This one here, I don't know what the pH was on the water here, so I'm not real sure how that's going to react and if that one's going to change. Now we're going to keep watching this one, but I'm going to show you the fun of this experiment in our other beaker here. Now this one is, I'm going to pour this water out so I can just pour it into this glass here. And then you will see the magic happen. So I'm going to put some water in this one. There you go. And you can see that, yeah, it's hard to dilute that. I could probably put 3 times this much water in there and would still not be able to dilute that. Okay. So as you can see, this is a slightly blue container, but when I pour from this container into our glass, we're going to see something happen. Okay, remember this is a chemical traffic light. As I pour into the glass, there's nothing else in this glass. Okay, this glass is no different. There was no other chemicals in there. And you can tell because this one just changed to that nice red color. So now that I have this one changed, I'm going to shake this one up and we're going to get things going. This one just turned from red to green, right? And then if we let it rest from that green to red, then we will go, there is a yellow, just like this one here. Remember how I just poured this one and this one was red? Now this one is yellow, okay? So now I have a green, a yellow, and a red, okay? Now, red is that middle state, okay? So if I continue to shake my red, it's going to turn green. This one here, if I pour this one back into here, you're going to see that we get a nice color change. You can even see that color changing in the air. So we're going to give this one just a second. Oh, wait, this one changed back to red. So we're going to see if we can turn this one back to green. Now, the reason I like to say that this is a New Mexico traffic light is because you never know what color is going to happen there and how it's going to react. Oh, yeah, I had to say it. Sorry. So we've got this green here. This one is that nice and yellow. Now, yellow is when I'm doing this with a classroom, I'll have them call out what you're supposed to do at these different colors. And at a red light, you stop. At a yellow light, you go really fast. You can see that this one turned from green to red very quickly. I still have my yellow in here. Oh, wait, now it's yellow. So this one is a fun one to do if you have like multiple students or a large group of students, because you can say, okay, well, when I say that this is red, or when you see red, you're going to stop. When you see green, you're going to go. And then when you see yellow, you're going to go very fast. So when you just call it out, now, you're at home, you can call it out when you're at home. I know now that this is green, so you're going to say go. Oh, wait. Oh, this is red. Okay, so you're going to say stop. Okay, so I know now that this is red, so you're going to say stop when you see that. Okay, so now, now that this one is green, you're going to say go. Okay, so there's a fun one that you can kind of take this a long way with this particular one and get a lot of chuckles. And so this one here, chuckles. Yes, I am a 94-year-old man. This is a fun one because it does look like magic, but that change there, woohoo, is just like if you saw our last one, our discrepant event, right? That change is nothing but science. And we can see it happening as it's going there. We see it going from that yellow. Now I'm spilling here. I've got plastic under this. Don't worry, I'm not getting it on the table. So you can see here, and as I said that, of course, then I would spill a whole bunch. But as you can see it changing color in the air. This is a great one. This is actually a high school level chemistry experiment. but it is a fun one to do even if you've got younger students because they can see that color change. And this is oxidation and reduction, okay? So reduction is when we are getting those electrons. Oxidation is when we are getting rid of those electrons. This one you can do at home very easily also. Like I say, the only one that is that you want to be careful with is this sodium hydroxide. The rest of this stuff you may have at home. This one goes by a couple different names. You may find it at the health store, dextrose, glucose. This one you can get on the internet. This one is a little more pricey. You usually have to go to a science place now because even though they used to use it for dyeing clothes, they really just use it as an indicator for science now. So our chemical traffic light is this color changing. I'm going to see what happens when I combine these two here before we wrap up. I'm going to see if well, let's see. I'm going to pour into this one first. We can see if I can make a little bit less of a mess. There you go. And then we're going to see what happens. I'm going to put this on there. So we're going to see what happens when we pour this into our yellow. So right now I have a green and a yellow, and yellow and green should make more green, but instead we get a nice, pretty red color. Okay? And so that should stay red for all of like pretty much absolutely no time. You can see it going from the bottom up, and we're getting that beautiful yellow. So this is an oxidation and reduction experiment. As you can see, it's a little messy. None of the materials in here are going to hurt anything. I do have plastic under my tablecloth, but the materials won't hurt anything once you have this mixed. But before this is mixed, you do want to be careful with that. You do want to have an adult around. As I said at the beginning, my name is Mr. Dave. I really appreciate you guys watching. Make sure if you're watching this later on the internet, let me know what the time was that this one changed. All right. Well, as I like to end everything, don't forget that science shows you matter.